Welcome to the distance learning program presented by InnoBest on JUnit. So before knowing JUnit, it's very important to know what is unit testing. So let's see something about what is unit testing called as. What is unit testing? Unit testing is a software development process in which the smallest testable parts of an application called units are individually and independently scrutinized for proper operation. It means that unit testing is a software development process in which we test the smallest testable parts of an application. The testable parts are nothing but the business logic, what the programmer codes in his or her program. So, all the smallest programs are individually and independently tested by every programmer, scrutinized for proper operation. It means that each and every small program will be examined or inspected closely and thoroughly for proper operation. So unit testing is a very important phase in our software development process to deliver our enterprise application. So this gives a quality product for a customer once we follow this unit testing. So unit tests allow a programmer to ensure that all features are correctly implemented, maintenance hasn't broken any existing code. Unit testing is basically done as automation process, but it can also be done manually. Unit test the following features of components like interface. So interface, it means that we test the proper flow of information in and out of component. The components are nothing but an application. So basically we verify the flow of an information which is going inside and outside of our application. Next is the local data structure. It means it will verify the integrity of the data during all steps of algorithm. So whatever steps or the program statements we code, so it has to be tested or verified in your method or functions of your program. Boundary conditions to ensure component works properly at different boundaries. Independent paths to ensure all independent paths have been exercised so as to cover every statement. It means we have to test each and every statement of the program written in your application. So all these paths are to be tested in your application. Error handling paths, these are very important to cover all your error handlings like exceptions. Generally we call in Java exceptions which will handle the errors. So even in unit test we have to see to it we properly handle the exceptions thrown by our programs in your test cases. So unit testing we saw, it's all about testing your program in written application, but unit testing with JUnit, let's see what it is. JUnit is a unit testing framework for Java programming language. So you do all your unit testing of your program through this JUnit, which is nothing but a testing framework. So it says J indicates it's a Java programming language. So basically this JUnit framework is meant for Java programming. JUnit is important in the test-driven development and is one of the family of unit testing frameworks which are called as XUnit. So this is one among XUnit family. JUnit promotes the idea of first testing, then coding. It means that once you collect the requirement of your application, you need to start writing test cases and then start writing your test cases for your requirement before implementing or coding those requirements. So it says JUnit, whenever you use in your application, you have to start writing JUnit test classes for test cases of your requirement before doing any kind of actual implementation or coding. So it's a very important idea which says first testing then coding. This approach is also like Test a little, code a little, test a little, and it goes on. It means you write a test and then code for that test once the test is successful. You have cleared the test case, and it is working successfully for your test scenario, so continue coding it. It means that. So each and every test case is successful, you can start coding it. This is one very important which you have to follow. Features of JUnit. Some features are like JUnit is an open source framework. It means that it is easily accessible from the internet and you can download it and start working on it. So it is an open source framework. Provides annotation to identify the test methods. So annotations are very much useful in this test methods because it provides basic annotations in your JUnit. We will see all these in your coming slides. Provides assertion for testing expected results. So again, assertion is also one of the feature which we are going in further slides. So it's very important that annotations, assertions, all these are the features of your JUnit, and we'll see what are these used for. Provides test runners for running your test. JUnit test can be organized into a test suites containing test cases and even other test suites. So what are these test suites? Again, we'll know these terms in further coming process, but it's all these important features we have to follow and know in development of JUnit test classes. So JUnit tests can be run automatically. JUnit is elegant and very simple to code. Now we know the features of JUnit. So let's go and do environment setup to start working on our JUnit. For that, let's see what are the need for environment setup. It's very important to have your Java installed in your machine for your JUnit to work. As I said, JUnit work on your Java development environment. So you need to have Java installed in it. Basically, you have to have 1.5 and above to get the features of it. So here in this, we have 1.6 installed and we are setting this path in your environment variable. Generally, it is in my computer properties where we set this environment variable under Java home. So you have to set this path for Linux and Macs as follows. Step 2, download JUnit archive. So this is very important part where we download the JUnit jar file from this following site. This is the generic and standard site where we get all the latest version, documentation and many more using this site, that is junit.org. So install this jar file and keep it in your any of your folder or drive you want. Here it is in C drive. Step 3, set JUnit environment. So once you have installed or downloaded the jar file, you need to set the JUnit environment. How do you do that? It's the same process. Go to environment variables and set your JUnit home for your location of JUnit jar file. Step 4, it's set the class path variable. This again the same place location where in environment variable will set the class path for your JUnit home, which takes JUnit whichever version you have. Here it's JUnit 4.10.jar. So you're locating that in your class path. So these 4 steps are very important for your JUnit to work and develop your JUnit test class. Next is life cycle of JUnit. So in order to start with JUnit, we need to know the life cycle involved in JUnit. So what are these life cycle methods? So it is the test case. Test case is nothing but a class which consists of test methods for your Java application in order to test it. The first thing is the setup. The setup method, it says that it's a method where you write all your pre-processing requirement. It means that any kind of pre-processing like initializing your object or initializing your collection object, initializing your array or connecting to the database. So all these initial requirements which we call as pre-processing, statements can be written or must be written inside your setup method, and this is one of the life cycle method which gets executed first and foremost in your test class. So test class will contain setup method as a life cycle method. Next we have test. Test is nothing but your test methods where you write your code for running all your programs of your methods written in Java class. For each and every method in Java class, you write a test methods in your test case class. So test is also a life cycle method which gets invoked by the JUnit after setup. So next is tear down. Tear down is one of the important life cycle method. It has to be written in your every Java class file. Tear down, it means that it says that any kind of post-processing, any kind of processing statements are written in your tear down method. Post-processing, I mean releasing all your resources. So once you're done with testing the methods, you have to release those. For example, I've initiated the object in setup method. I've used that object in test method and I have to release that, right? You have to release that reused object or any kind of resource in your tear down method. This method will automatically get invoked by JUnit class when we run or execute your JUnit. So that's why these lifecycle methods are must to be written in any JUnit test class. So when I talk about more on tear down, as I said, it's important. Suppose you have to connect your database. You require a connection and establish a connection, right? So at end of the test case method, you just write the resource release in your tear down. So it will automatically release your connections or close your connections by methods getting executed in tear down. So these three lifecycle methods are very important in JUnit. Next is annotations. Now annotations are very important in JUnit because it identifies and signifies what your test methods or methods in test classes does. So we will know what are the annotations provided by JUnit to write in your Java test class. So these are the some of annotation listed here. There are many annotations there in your API which you can see once you download from the internet, and you can list down and see all your API Java test class annotations. Some of the basic and very much generic methods which you find in your test class are annotated with test. It means that any method with annotation of test are test methods. Test methods will test your methods of your Java class. So you have to annotate that in your test class with test. It indicates it is a test method. Next is a before annotation. It means that the method annotated with before will be executed before executing your test method. So if you see earlier lifecycle method, there was something called setup, right? So if you annotate that with before, it means that method will get executed before your test method. So before annotation is very important with setup lifecycle method. Next is the after. At after, it means that very clear after your test method has been executed and after your before method has been executed, it gets executed. The after will get executed after each test method. So this goes with your tear down. So tear down will come along with your at after annotation. At before class. At before class, at after class, at ignore, all and at test with expected equal to exception of class. All these annotations were added in later versions of JUnit 4.x onwards. It was not there earlier. It got recently added here. So at before class, it means that this method will be invoked only once of your execution of class before executing any of your test methods written here in your test class. So it gets executed only once before executing any of your test methods. After class, even this is called only once. This method will get invoked after executing all your test methods. Ignore it very much understood. It will ignore the test method to be executed. It will not execute the test method when you annotate with ignore. And at test expected equal exception class, this is very important for handling your exception, and it makes very easier to handle your exception in your test class. And all these annotations we'll see more in detail in coming up practical demonstration of our JUnit. So you will know much more about these annotation usage. Next is assert statements. As annotations, assert statements are also very important in JUnit. These are assert statements. It just does nothing but giving the specific error messages. Once you execute the test method, it says what was expected and what we have got actual result. So it just says the expected and the actual result. So there are certain methods, built-in methods, which you get it from your API. There are many, but here some of them which are generic assert statements seen in your test class, listed in your slide. You can see more in depth if you have your API downloaded. So these are the basic and generic which we use. Fail string. It means that the method will get failed. It means whenever you check that a certain part of the code is not reached, then the method is failed, or having a failing test method before test code is implemented. So that time we use this fail. Assert true. Assert true is also very important. It means it verifies any conditions having boolean in it. Suppose you have to check some conditions telling this equal to this. So if it is equal, it says yes, it is true, and if it is false, it says false. So in those conditions or those business logics you have to test, then you have to use assert true, something called assert true. These assert true are overloaded with many different arguments or parameters, what you call. It has been overloaded in JUnit. You have many different kinds of assert true with different parameters or arguments in it. So our assert equal, even this is very basic and generic, and you see often used in any test class. This equals is also a test two values are the same or not. If both the values are same, it means it is equal. So it will give respective error message or result message telling this is expected and this is actual after checking if two values are the same. And next is asserts equal. Again, this has been overloaded by different parameters in it. So you can go through it, all these statements, when you can use it and what to test, where to test, to verify. You can use all these assert statements. Assert null, it checks if the object is null. And assert not null, it checks object is not null. Assert same, it says if both the variables refer to the same object. It means if the variables are referring to the same object, it says yes, assert same, we can use it, and that time we have to use this assert same. And if you want to see if both the variables are referring different objects, to verify that, we use assert not same. So these are basic and generic assert statements which we often see in our test case classes. We again see all these things in our demonstration coming up slides, which we see further. JUnit project preparation. So we are done with environment setup of JUnit, and we know something about life cycle and then assertion, annotation, many concepts, many features we got to know. Next thing is start working on it. So to work on it, we have to do something called project preparation. So we have to have project structure followed to have our JUnit test classes. So let's see that how it is done. I need to create a Java project. So Java project, why you need to create it? It's because JUnit framework is used for Java classes. So let me create a Java project. It says JUnit test. And then I'm finishing it. So here, if you see, it has created me a source folder with GRE JDK environment path and build. So now I have a source folder. I generally create a package to organize my Java files. So it's the best Java practice. You have to organize in packages. So let me give package name as com.inobus. This can be anything. You can name it anything, but this is standard to start with com and then followed by any name what you want to give specific to your package, indicating some valuable structure what you follow. Here I'm following with this tutorial. So in OBS I've given, you can give anything. So once I'm done with creating a package, I'll click finish. So here if you see, it is a JUnit project got created with my source folder and an empty project I've created to have my Java files. Next, for JUnit, what you need is, I need one more folder. I'll create one more source folder, which will tell me test. This is very important to write as a test because it indicates that you have written all your test files for your Java applications, programs which you are testing it. So I'll create a new folder test, and next very important thing is I have to follow the stream structure of your source folder. So what I'll do, I just copied this package and I have pasted inside this test folder. Now if you see the structure, the source folder follows with package. Also the test folder follows the same package. Here the structure should remain in the test folder same as the source folder. Whatever packages you have to maintain the same structure inside your source folder. Now this is the basic structure of your JUnit, which is followed in enterprise level. You can use this for enterprise level applications, but if you don't want to go in structure level, you want to just test one single file, you can create the same test file inside the source folder. You need not create all this. But if you have enterprise application which will have many source files, many test files, then you have to segregate and have this kind of structure followed for your JUnit classes. So it very well says you have to have a source folder with all your packages and follow the same structure in your test folder. Okay, this is the generic structure or a project preparation for your JUnit. Now let's see what is next in our course. Next is creating a Java class. So once I'm done with my project preparation, I will create a Java class. The reason I need to create a Java class, it's very simple. I need to test on it, right? So for testing your JUnit, you have to have some Java classes. Let me create a Java class. So let me call a Java class as calculator and then finish. So this will give a simple template of your Java class. Here I'll just write a simple method. So method inside this class, public int add, which takes two parameters x, y, and then returns the addition of these two parameter values. Yeah, we are done with creation of the Java class called calculator, which does some kind of business logic inside add method by adding two parameter values x and y. Now let's see what is there in our next slide. We are done with creation of Java class. The next thing is creating JUnit test class. Yeah, we need to test the business logic method which is there in calculator class. So let's begin writing our JUnit test class. So where do we write? It's very basic that we have to write all our JUnit test classes inside this test folder. As told earlier, this is the basic structure. Let me select this package inside that and right click, new, go to this other, and then you find JUnit test case. Where is this? I'll show you. It is there inside this Java folder. So once you expand this, you can find something called JUnit, and once you expand that, you find JUnit test case, and this is required to create your JUnit test class. So once you click next, you can find where you have to give the name for your JUnit. Let us give as calculator, and then suffix with test. When you write the name or any name, you have to follow best practice, or we can say standard common uh, logic. Keep in mind, or whatever, you have to know these best practices while naming your file names. So here in terms of JUnit, it is very necessary that you always name and give the name same as your file, that is Java file on which you are going to test. So here I am going to test on calculator Java file, so I am giving it as calculator and then suffixing it with test. Yeah, this is very important because this says this is the test class and I am going to test on calculator. The name itself says. So follow this best practice in your JUnit when you start writing your test classes. Now, after that, we see something here, test lifecycle methods already present where you can check and uncheck to include in your Java test class. So as I said, these lifecycle methods are very important. You need to have these methods inside your Java test class. So I'll be selecting everything so that it comes automatically in your Java test class once you have created. So here there's something called class under test. What do I need to write here is you need to write a complete package path of your Java class on which you are performing the JUnit test. So here I'm performing on calculator, which is there inside this one. Okay. Once you are done with this, click on next, and then you can see automatically there is a calculator method coming up with the methods inside this Java class. It says that this is a Java class and these are the methods. And do I need to perform the test on these methods? Yes, I need to write a test method to perform the JUnit on this method. I'll select this and then finish. Once you click finish, see that you can see this pop-up window. It shows you JUnit 4 is not on build path. It is not there in build path because I have not added that in build path. If you have added, this prompt will never come up. I'll show you how you can add it. But in order to avoid that, now what I need to do is I'll add it through this window by performing the following action by adding this into my Java path. This is nothing but the library, the Java JUnit.jar. I'm adding it to my build path of this JUnit test project. Okay. Once I'm done with this, selecting this, you click OK, and then you see here in left hand side you can see JUnit has been added to your build path, which has got nothing but your JUnit jar. So if you don't want to add through that prompt window which you saw just now, you go to this properties. There is something called Java build path. Here you can add your external jar. So wherever you have extracted your external jar, you can add it, right? So if you have extracted to your C drive, you can add it from your external jars. So now I've already added, and now it's there inside this. I'm clicking OK. I'm not going to add, it's already there added now. Once it is done, see this what is there in our test class, what just got created. It has got all the lifecycle methods and also the annotations in it, which are very much necessary, or else nothing will work. If you don't have these annotations, nothing will work in your test class. These are very important. Already we have spoken much about these annotations earlier. Now we have to concentrate on testing our business logic method of Java test class. Yeah. Now for doing that, what should I have? I need to have something instance of calculator class, right? I need to invoke the add method in it. So for doing that, I need to create an instance So I've declared this calc object, which is of type calculator. Now I need to initialize this object. So where will I initialize? If you remember, all the pre-processing statements will come under setup lifecycle method. So in this annotation you can see at before it will invoke before every test method execution. So in order to initiate your calc object, come to this lifecycle method before annotated, that is setup method, in which you will initiate the calc object with calculator. Once it is done, I have the instance of this calc object. Now I have to perform the testing on the method inside this class. So what was that method? It's add method. So to do that, if you see, there is something called test add. So this method, I need to write the statements needed to perform testing. So if you see your annotation test is which tells that this is the test method which is going to perform the testing on business logic method of our Java class calculator. Now I have created the object. I'll invoke the add method by passing the parameter values as 1 and 2. Right? I'm testing it. So I'm passing the values to that method. So now the class is complete. I have a test method with where I'm invoking the object of calc, which is of type calculator, and then invoking the method by passing 1, 2. So what will this do? It will just invoke that method, and whatever is written inside that method will get executed and then return you the result, that is x plus y. Now this will not end your JUnit. What should I do next? I need to verify, right? Whatever has been executed, I need to see that the test has run successfully and the code written in the business logic method is correct. So for that, what should I do? Assert there is something called assert equal. So for this, I need to import the package of assert. Here, let us import. Should come by default, but it's there inside JUnit dot assert. Can you see this? Yeah. Import this, and then here, if you come here inside this test method, you have to see it is. See, actually, what's happening here is I am invoking all these are starting methods. That's why all these can be invoked with assert class directly. Now, if you see, let me invoke this assert equals having 3 parameters. The first parameter says message. In this, you can give anything. Now, I'll give result of addition. Yeah, because I'm checking the add method result. Now, this is the expected. Expected means when I know that I'm passing 1 and 2 here in this invocation of the add method, the expected will be 3, right? When I pass 1 and 2, 1 plus 2 will be 3. And what will be the actual? Actual is the one which I have passed and got the values. So what I'll do is, I'll initiate the variable result with this invocation. So this will give me the result of the invocation of add method, and I'm going to check that or verify in my assert equals assert statement. So what does this do, or what it indicates is, whatever the method I'm invoking on this calc object in this test class, as being tested or executed and verified using this assert equals. After this has got executed, next thing is I need to verify. So this is the actual result what I have got after invoking the add method, and this is the expected method which I have to write what I expect from my add method. So when I know I am passing 1 and 2, I should also know what is expected, right? That is how you test. When you know your test case, you need to know what is your outcome of it. So this is how you need to test your JUnit. Now JUnit is written. This is the basic JUnit test class having all your lifecycle methods, and this is the test method which is performing the test on your Java class called calculator, which we had written earlier, right? We are invoking that method and then verifying it using assert equals, which is nothing but an assert statement which has many, you saw earlier, it has got so many overloaded classes. Now we have selected 3 parameters overloaded method which takes message in it. You can indicate any message. And also this expected is very important. If you know you're passing 1 and 2 as the argument value, you need to know the expected result is 3. And you're verifying that with the result. After actual invocation of your add method, you're comparing these two values and then verifying it. That's what the assert equals tells. You're checking if the values are equal. I'll show you one more example of assert statement, which is assert true. We had seen earlier assert true. There are 2 overloaded methods. Okay, you can select anything. Now let me take this string and message. Again, this string also it can be anything. Here also I'll write the result. Just you can write anything what you want. And next parameter, if you see, it's a Boolean condition, right? It means you're checking the condition which should return true. Now minus calc, what you're performing is invocation of addition method. You're passing 1 and 2, I'll pass 1 and 2 the same here. Or let me give 1 and 3. Okay. After execution, what should I get? It should be equal to 4. Now, this completes the assert statement, which is of assert true. So to be more readable, let me put the parenthesis. So here what it tells is, I'm invoking this method of Java class calculator and passing the values 1 and 3, where the add method does addition. After addition, it returns me 4. If it returns me 4, it means it is true. If it is returning something else, it is wrong. Okay, so this is how you test by various assert statements, various asserts. You can test and verify your expected result out of your test method, what you have done by invoking the business logic method written in your Java class. So this is the basic Java class JUnit test class. This is also a Java class, right? But this is a JUnit class. It is indicated by, as I said, by name of it, which says test. The name says it's a test class, and then it has got all lifecycle methods with all annotations in it, and these are all invoked when you execute this JUnit test class. And once you are done with this, we see what is there in our next slide. Next is run your test through Eclipse. Now we have already written Java class, and next is the JUnit, and now we'll see how to run this JUnit test class through Eclipse. Now This is the Java test class what we had written earlier, that is JUnit class. You have to run this, right? So how will you run these through Eclipse? For that, go to this calculator test on the left hand side in Project Explorer. Right click, something called Run As. In this you can see JUnit test. Just click on this Run As JUnit test. The JUnit will get executed and then show you the result in JUnit view. If you recall, there is something called JUnit view which shows you the execution of your JUnit test class. Here if you see calculator test, it is the name of your JUnit test class, and then it has got runs one cross one by one. It means that there is one test method called add, right? Test add, and that one test method has been run. It has been executed with 0 errors and 0 failures. If you see here, this green bar indicates the test method has been successfully executed and it has been success. It shows that your test case, what you have written to test your calculator class add method is been success. It has been succeeded and it is correct coding what you have performed, right? So this is how you run the JUnit test class through Eclipse. Now, let me show you some additional details. Now, we have already run this test class. I'll also show you some additional details on how this lifecycle method does. Yeah. So for that, what will I do is, I'll close this, go to Package Explorer and open this calculator. Let me add one simple method. This time subtract. Again taking two parameters. And returning the subtraction. Okay. Once you're done with, I've just added one simple method to the same Java class, subtract. So I'm going back to the calculator test class. Here I'll add that method. Test subtract. Yeah. So if you see in JUnit, there's one more best practice which should be followed. Naming of your test method. It's very, very important. How will you name your file name? The equal importance should be given when you name your test methods. In this test method, you are prefixing with test, which will tell you that this is the test method, and suffixing with all your Java class method. This is subtract method, which I have just written as it is in your Java class calculator. Now you can write anything. You need not even prefix test or write a suffix with any subtract method. You can write ABC XYZ, but following it, it's again a best practice or a standard which you need to follow when you're writing JUnit. So this is the advantage, and readable, more readable. Next thing is, I need to invoke the subtract method, right? So again, I'll do the same thing. I'll initiate the result by invoking the subtract method, passing 3, comma, 2, or 1. So we are done. Next thing is, I'm testing with or verifying it with assert statements. It's the same process. Select anything. See, assert equals, if you see, there are so many methods which has been overloaded, right? You can select appropriate methods based on your requirement. So here I'm just selecting the same. Which has string message in it, just result of subtract, then expected. So we've already given what is input value. What we are passing is 3 minus 1. If I pass 3 minus 1, the subtract method will subtract 3 minus 1. So what should be the expected is 2. So I write 2 here, and the actual I'm actually comparing with the result what I get after execution, the business logic method written over here. Yeah. So once it is true, it means I have verified and it has been successfully executed. So let me execute this test class, run as JUnit. So if you see, there are two methods. Wait, see, it's showing one method, right? It has not executed test subtract. The reason being we have not written or annotated with test. Do you remember, if we don't write any of the annotation necessary for JUnit test class, nothing will get executed. And this method didn't get executed just because there was no test annotation. Now it has been annotated with test. So we will again execute that through Eclipse, run as JUnit. It has been executed. You can see here runs two test method out of two. Both the test methods have been executed and there are no errors and zero failures. So when you expand this, test add and test subtract has been done. Now we have added one more method and we have also tested that method in calculator test. The reason being of me adding this additional method is for you to show how these life cycle methods work. Now let me show you how it works by putting some sysout statements. Okay, we are putting the sysout statements just to show you when these lifecycle method gets invoked. So as per annotations, it should invoke before, after, all those should follow those rules what are given in annotations. So we'll check the order by which the JUnit works, especially the life cycle methods. We are much interested in knowing these before class, before, after test, how these will be executed in your JUnit framework, how these life cycle methods actually get invoked one after the other. So I have put all the sys statements. Now let's execute and see this test again. When you run this, it has been executed successfully. But see in this console, if you see in this console, there is something called setup before class coming first, right? I told you earlier, this is the method which is annotated with before class. It means that it will be executed once of your execution JUnit class before executing any of your methods inside this JUnit test class. So this has got executed first. Next is setup. When you have this setup, it will always get executed after your setup before class. The setup method, which has got annotation with before, will get invoked before any test methods. Okay? Before any test method, the setup method will get executed. Let's see what is getting executed next. Next is the test add. Test add is the one which has been followed in this order. After test add, we have test subtract. But here, once the setup has been called, we are calling the test method test add. And if you see tear down, so tear down is the method which will be invoked after calling your test method. Every test method execution after completion will be invoking tear down. Now, why is this tear down method? As I said earlier in our life cycles method, it is used to nullify or release our resources. In this class, the resources, the calc object which was being initiated in your setup method. Yeah, you saw this earlier. All this pre-processing or initiating statements are written in your setup. Now the teardown will be releasing it by just calling now. So once you have performed this test add, I need to nullify it. And next, we'll see what is there in your lifecycle method invocation order. It is the setup. So after setup, we call set test subtract and again tear down and finally tear down after class. So if you see this order, after every test method we are calling tear down and before every test method we are calling setup. So if you see, there is a setup, test add and tear down. Again setup, test subtract and tear down. But these test setup before class and setup after class will be called once in your class execution. Setup before class method, that is this class annotated with before class will be called before executing any of the methods. And here if you see setup after class annotated with after class will be executed after executing all the methods at last, after executing all the methods. Whereas setup and teardown, it will be executing every time when you execute single test methods. So this is the order in which the JUnit framework works by using all your lifecycle methods. This is how it works by executing the lifecycle method. So here we saw the lifecycle method executions. Now let's see. We also saw executing it through Eclipse, right? We selected this and then run as JUnit. This is how you run the code through Eclipse. Now let's see what is there in our next slide. Next is run your test through Eclipse. So this we have already seen, right? We just did right click and JUnit test. I showed you. So the result will be shown in this JUnit view. This is the JUnit view which shows you the green bar showing your test class being executed. Run your test through code. So far we have executed the JUnit through Eclipse. Now let's see how can we execute it through code, right? Let me write and show you in practical demonstration. I'll go back to the same class what we are maintaining in throughout the course. Now this is the Java class. Running the test through code, it means you can run the Java test class, that is JUnit class, within this Java code. How do you do that? I'll show you. For that, just write main method in this method we have something called JUnit core. So this JUnit core given by JUnit framework consists of run classes. Now this method will allow you to run the test class within your Java code, that is Java class calculator. In this scenario, what is the test class I need to run? We have a test class called calculator test, right? So this class I need to run within this Java code. That's it. JUnit core, where is it coming from? It's coming from or.junit.runner.junit code. And this is the package from which we get this JUnit code, and then the method inside this package or class will execute this test class, that is JUnit test class, calculator test within this Java file. Now, once we run this, we'll get some result out of it. So for that, We also have result provided by JUnit package. I'll show you what is that. You can see org.junit.runner, right? So this is the class which can it will hold all your outcome of your run classes. When we execute this test classes, whatever is the output will be initiated or initialized to this result instance, which is of type result, which is coming from org.junit.runner. So here, after execution, it can be failure, it can be errors, whatever it is, any output will be sent to this result. And once we have that execution, what we can do is, we'll just see, I said you can have some failures as an output, which is there inside the result. So I'll give failures, but I'm iterating this with failure. What is this failure? Again, failure is coming from JUnit package runner.notification. Inside this package, we have failure class. Okay, I'm just using this class instance because the result object, which is provided by JUnit, will hold the failures of your Java unit. So in this case, I can iterate all those failures and then you can do anything. You can print those failures, right? So here I'll print I need not write this. Let me print it here inside this method, which tells what is the failure, what you have got. So that you can find out by writing this failures. Yeah. So here in this piece of code, yeah, it's just 2 lines of code by which you can run your Java JUnit class within the Java class calculator. Means in any Java class you can just run by using this run classes method provided by JUnit core and then execute any of your test class, and then once you execute that test class you will get a result using which you can check the failures if you have got anything. Failures can be exceptions, errors, it can be anything. So all these can be shown or used, or you can give the feedback message, output message that you had this exception, or adding those messages using this iteration. So this is a simple piece of code which will be used for running the JUnit test classes within your Java class. So this is how you run the JUnit through the code. So once we are done with it, let's see what is there in our next slide. So this we have seen already. Yeah. Next thing is, I've already mentioned these things. So this class provides, JUnit core class provides run classes method which allows you to run one or several test classes. So in our practical demonstration just now what we saw, we have executed one single class, but here run classes says it can execute any number of test classes. You can just execute that by giving comma as delimiter. You can just go on appending whichever test classes you want to run. Yeah. And next thing is, as a written parameter, you receive an object of type which I have already told you org.junit.runner will give you the result with which we can check all the failures what has been given as an output from executing your JUnit test class, and that you can check in the result instance by using get failures method. We have already seen that. Next is JUnit test suite. So what do you mean by this? JUnit test suite is nothing but we'll explain it. What is this JUnit test suite? We'll see what is that. I'll show you in the next class. It shows JUnit test suite. But let me tell you what is this test suite all about. It's nothing but run several tests can be combined into a test suite. Running a test suite will execute all tests in that suite. So its suite is a basic general English word which says obviously you can combine everything. It's a class consisting of all your test classes and executing all at a time in so-called a suite. So test suite, as name suggests, is a combination or collection of your JUnit test classes which can be executed at one go. All several test cases can be executed. I'll show you how. And here the wizard shows how you can create the test suite. Just right click on it and create the test class what you want to run. Now let me show you how it works, how we can create the test suite practically. So coming back to the example calculated test, which is the JUnit test class. In this, what we have to do for creating a test suite, right click on it, go to new and then go to other. We already have JUnit folder in it. If you see there were two options, one to create the test class and another was to create test suite. I'll select the test suite option and then click next. Once you're clicking next, you can see here the calculated test is coming by default. If you had more than one test classes, it would have listed everything out here. But here in this Java project or in JUnit test project, I just have one calculated test. So it's coming by default and getting checked. I just need to do nothing because I need to test this execution of this calculated test and put inside my suite. The suite name here, if you see one more very important, it has given all test. So it is by default the name has come. When I have created new test suite, it says, it signifies I'm running all tests. Name can be anything. As I said, you can give run all my Java JUnit test. You can give all JUnit test classes or anything. Name can be anything. But as I said, there is a JUnit best practice to mention all test. All is because you're running more than one test. So all at a time. That's the reason it signifies all test classes. I'm done with this and finished. And you see here. This shows your test suite. Suite, if you see, this run with annotation is important. As I said, JUnit is full of annotation. Without annotation, nothing will get executed. So run with will use the suite class instance which is coming from runners package, and then suite classes will take the parameter n number of test classes. So this you can delimit with comma and append, go on appending the number of test classes you want to test at a go. So here, since there is only one test class, that is calculated test class, it has been mentioned here. And then once you run this, it will get executed. So let us run this class. So how will you run? You just need to right click on this, run as JUnit test. Did you see that? I just selected all test Java and executed it. So since the suite classes has got parameter list as calculated test, it has executed me the test class. If you have more than one test class, you can append it, as I said, through comma. If this is the test suite, how it works. And let's see what is there in our next course slide. Exception handling. Exception handling in Java. We have seen in Java we handle exception. The same way we have to have handling of exception in JUnit. And yes, JUnit gives the options of handling the exception. We'll see that what it is and how it is done. So here JUnit will provide an option of tracing the exception handling code. How will it does is, it is given us a parameter called expected which is used along with test annotation. So if you see here, there is an test annotation having a parameter with it as expected. So let's see the exception handling in JUnit, how it works. Yeah. Now for that, let me go back to calculator class. So this is Java class, if you remember. In this class, to test the exception, what will I do is, I'll just add one more class. Public int divide, which takes two parameters again. And then, what does divide do? It just divides x by y, right? So I have written a division method. So in this, it takes two parameters x, y, x by y. I'm done with this method. Now, if you see this division x by y, it does nothing. It just does division of two numbers. Now let's see how it can handle the exception and what exceptions. Right? I'll show you in test class. Now this is the calculator test class. For this, what should I do? Follow the same step. Create the test method by annotation of test. Very important. Public void. See, one more thing, very important. Every method in your JUnit should be public. Every method in the sense, all these life cycle methods should be public. Or any of the test methods what you have to test. Basically, test is a life cycle method. Annotation of test. So test method should be public, and all other lifecycle method you see all these things are public. So it must be public, or nothing will get executed. These lifecycle methods should be public, right? Now let me give a test method name as divide. So here I will have invocation, same thing. Invoke the method and pass the parameter of values one by one. Okay, I'll give one by one. You can give anything. I'm giving one by one. Now, once you're invoking, what is the next step? Verify it. Yeah. So let me select this now. I don't want any message. So expected. What is one by one? Expected will be 1. So when you divide 1 by 1, the expected should be 1. The expected you are comparing with the actual result what I have got by executing the method of calculator Java class, right? So this is you're comparing. So here assert equal without any message. It has only two parameters. So I'm just comparing with expected and actual. Now let me execute it. Yeah, it has executed. Now there are three test methods. So we had add, now subtract, and then divide. Now it has got executed successfully. Now let me see how exception is handled. For that, what will I do? I'll pass for division, that is divide method 1, 0. So what happens is, in this values what you're trying to pass for testing the division method, that is divide 1 by 0, it will throw you the arithmetic exception, right? In Java, there is something called arithmetic exception which will get thrown when you divide something 1 by 0. or any number by 0. Now, let me see how it shows. I've given 1, 0. I'll execute this test method. Calculator test, run as JUnit test. Did you see this? There is one single error. It is signifying me that error is in division. That is test divide method has got error. What is that error? Here, if you see in the left hand side, there is something called failure trace. So this trace will show you all the errors and stack trace of your exceptions and where and which line is failing. So here by division, if you see here, the line gets executed and fails and throws you arithmetic exception. And how is this invoked? This is invoked through calculator test class in this test divide method. So basically, we have thrown arithmetic exception. But I need to execute and handle this exception. For that, what should I do in JUnit? I'll show you that. So for test divide, there is a parameter called expected. Here I need to say expected is arithmetic exception class. It means that the test method has got executed, and because of passing this 1, 0 as an input values for testing this business logic method divide of calculator Java class, it has thrown me the exception, and I'm expecting that by using this parameter expected, which is an arithmetic exception. So this is how you handle along with our test notation by giving expected parameter as exception what you're expecting from your test method. So this is how JUnit handles your exceptions. Done. Now we are aware of exception handling. We have also seen through demo how it is done. Now let us resolve this, right? Let us resolve. How will you resolve? Remove this 1. Yeah, it is going back to the same. Just you want to remove the error, change it to 1. So that error will go off and you can take this off. Because once you want to avoid the error by giving 1, you can remove this off because no exception will be thrown. But here I want to show an exception, so I am making this input value as 1. By dividing 1 by 0, it will throw me the exception. Okay. Now let's see what is there. Next slide. Yeah. Mocking. So what is this mocking? Mocking is nothing but replacement of real objects through proxies. Proxies, it means that all the real objects are replaced with your predefined behavior of the actual object. And all these are done using Java proxy mechanism. So basically mocking as an English meaning, you just mock, you just proxy of real-time object and provide mock object to act as the real object by predefining the behavior of your real object. That is what is mocking. You're disguising or you're acting how it says in English. It's the basic meaning of it. But in JUnit, what is mocking all about and what actually we have something called mocking dealing with in JUnit test class. Let's go and check it. Mocking of objects, as I said, in this case, the real object is replaced by a replacement which has a predefined behavior of the test. There are several frameworks available for mocking. Popular mock frameworks are EasyMock, JMock, and Mockito. So, EasyMock is the mock which we'll be reading in our training now, but rest of the mocks can be read as per interest. Easy mock because it goes along with JUnit. So JUnit, we know we go with easy mock, which comes along with the JUnit. So easy mock is a popular framework which can be easily used in conjunction with JUnit. So as I said, there were other popular mock frameworks also available, but we are going with easy mock. Even this is very much popular, very useful, and now it's current useful in the market where it's used everywhere. And this mock framework, it will go along with JUnit. It works conjunction with JUnit along with it wherever we do testing, unit testing. So JUnit comes with this. Next is the easy mock provides mock objects for interfaces and objects by generating them on fly using Java's proxy mechanism. As I said, all these mock objects are generated by Java proxy mechanisms, and because of these mechanisms we can do many things. Testing has become easier because of mock objects, and these are mainly for all interfaces and the services. And let's see how all these actually work. In our further slides, we'll see in practical demonstration. Now, how will we work on EasyMark? You need to download this EasyMark using this open source software. This is an open source software, and you can find this downloads in easymark.org. This is the site which gives you all the latest version and documentation for EasyMark, and you can directly download from this slide or site. Yeah, you can see that in the slide. Whichever is the site, you can go there and download it. Once you're done with downloading, now let's see how this life cycle of EasyMark work, or what life cycle will provide in EasyMark, right? EasyMark, we have something called 4 life cycles, yeah, and those 4 are create mock, expect, and verify, replay. To begin with, create mock, this phase creates the mock object. So this is where you create the mock object using create mock method. This is the life cycle method given by EasyMock. And next is expect. In this phase of life cycle method, we will record the expected behavior of the mock objects. These will be verified at the ends. Once you record all the behavior of your mock objects, we will be using it further for verifying it. And replay will does the job of verifying it by previously playing the records. It will just play the record of what you have recorded in your expect lifecycle method. And verify is the method where you verify all the tests, whether it has been passed or executed, or the order in which it has been executed, and expected as per behavior. The verify phase confirms the execution of the expected calls, and this will tell you all your expected calls has been executed in given order according to your mock usage, which method you use. And all these 4 lifecycle methods are very important in EasyMock, and these are very much often used in your EasyMock unit test class. So here, moving further, we will see all these lifecycle methods, how it is used in our EasyMock demonstration. So EasyMock, it has got some strict mocks and order checking. So how it is done in EasyMock is using create mock. So earlier we saw create mock as a lifecycle method. So what does this do is, why it is called normal, because here EasyMock will not check any order in the way the test methods are executed. It means that the order in which the Java class has got the methods, the business methods, the same order are not necessary to be followed in your easy mock class. Yeah, in your test class, you need not have the same order in which the Java class executes its Java methods. That's how this create mock says. And next we have strict mock. Create strict mocks. Here we have all expected method which must follow expected arguments in a specific order. Calls to be noted that the order in which we do invoke in our Java class, the same order need to be written or followed in your test class in a specified order. So, calls to unexpected methods will always fail in this create strict mock. It means whenever you call unexpected method which are not required in your test method, it will fail. That's why you say strict mock. And strict mock is really very useful when you want to test your Java code thoroughly and step by step. The correctness and all validity is coming only through create strict mock. And in order to follow that, we have to use this strict mock. Nice mock. Nice mock is again, it doesn't follow any order. All expected method will even though contain specific arguments, but it is in any order you want. Here order doesn't matter. So here calls for any unexpected method will not cause any test failure. So nice mock, create nice mock and create mock will not follow any order, whereas strict mock follows respective orders. So this is the category of strict mocks and order the way it checks in easy mock. Next is test execution and debugging using easy mock. So I'll show you the demonstration of easy mock. Along with this, I can also show you the debugging, how we debug the JUnit classes and also how you execute. Execution we have already seen, but easy mock also follows the same. You just need to follow the same steps what we have done earlier for JUnit execution. Debugging, I'll show you how you do it. For any JUnit or any test class, you follow the same. So let's go to easy mock demonstration. Now, for that, what should I do? There is a source folder. We have already created this package. Now, what will I do is, in order to show and segregate the easy mock demonstration, I'll create one more package. It's better for readability, right? So, what will I do? I'll follow com.enobus.easymock. So, inside this package, I'll place my easy mock files, which I need to test, right? So this is under source folder. You remember the structure should follow the same as in test folder as well. So what should I do? Copy this package EasyMock what I created and then paste it inside the test folder. So this structure will remain the same. Now I'll create one interface. Okay. I'll explain you how EasyMock works. Now currently I'm creating a Java interface. Let me give as multiplication service. So this interface will act as a service of providing some service method. And I click finish. This is the interface which has been generated. Now here I'll write the service method. What will that be? Int multiply, because the service says I'm multiplying. So I am just taking two parameters and then declaring the service method. So there is just a Java interface created called multiplication service which has got multiply method declared in it, right? So this has been created. Now we will test the mock, easy mock. For that, what should I do? I have this package already created. What should I do further is right click on it create a new class which should be JUnit test class, and then give the name as easy mock test. Okay, you can give any name. So I'm just giving any easy mock name. So once it is done, I'll click finish. Okay. Now these are all the JUnit test methods, lifecycle methods. It will not harm anything if you have that in easy mock test. It is always better to have it because all the pre-initialization you need to do in setup and all the releasing of resources need to be done at teardown. So these are all necessary. So I have added those in easy mock test. Now I have something like this created. How this mock works? For that, what should I do is create an instance of service interface which I have just created. Yeah. Now specifying this with mock, suffixing this with mock is important because I'm mocking the service object, right? You can give anything, but as this is also one of the best practice to be followed. Any mock object you suffix with mock. It says this is the mock object, not the actual object. So how will you initiate or how will you initialize the mock object? And one more thing, where will the initialization part go? It goes inside the setup method, right? So I am just going inside this method and this initializing with easy mock dot. See, if you see there is an error, you know the reason behind this error? Because I need to get the jar file. What will I do? Go to properties of the JUnit project, add external jar. I have the jar file EasyMock downloaded in EasyMock site which I had shown you earlier. Download the EasyMock jar and I placed inside the JUnit jar. Inside this I just need to take the EasyMock jar and then add it. Once you are done, click OK. So when I've added that to build path, you can see here I've added this EasyMock jar file inside this JUnit jar, this project. You can see that to the left hand side, I've added EasyMock. Once I've added, I can get EasyMock coming from org.easymock. Select that and then there is something called EasyMock create mock. Do you remember we had lifecycle method called create mock, but I'll create strict mock because I want my Java class to be tested at correctness and follow all the order. So for this you have to give multiplication service class because we are creating a mock object for this interface. So this is how you create the mock object. This is the life cycle method of your easy mock. It goes without saying that it create mock object, but here you can use create mock or you can use create nice mock. I'll show you. If you have, you should also have APIs downloaded because it's very important to see different types of methods available. So this is the strict method, and if you see, it has got even the nice, create nice mock, create mock. There are many overloaded methods. You can use any method based on the requirement. Create nice mock. You can see here even these are overloaded with different parameters, and create strict mock. Okay. So here I've just created the strict mock and then passed an interface to create a mock object for this interface Java class. Now, once it is done, the mock object is available. I need to just do what? Invoke the object method on this object. Yeah. What is that method? Multiply. This is the method which is available in my mock object. So, whenever you do this, what happens is it will invoke in your service method, that is multiplication service method. But this is not done yet. You need to do still more much. This is the basic invocation in JUnit, but in EasyMock we saw lifecycle method, something called as expect. Right after create mock, the next lifecycle method was expect. That is expect, which will expect the result of your invoke method, right? So here, what I'll do, I'll put this top, and this is what I'm invoking, right? And then, whatever the result is being there, I'm just adding it. Yeah? In expect, I can directly add this instead of putting there. I can directly expect this and then call and return. So what will this do is, I'll tell you what it does. And return 1 into 2. It is 2, right? Yeah. So here we have written a statement which is statement from EasyMock. So in EasyMock, if you have to test anything, you need to write lifecycle method of expect provided by EasyMock, which takes argument as the mock object what you are expecting. As told earlier, what does this expect do? It just records the behavior of what you have to be done. Invoke the service objects will provide this method, and you're just expecting this and returning the result, that is 1 into 2 is 2. So once it is done, what is the next thing is, I need to replay this. This is again one more lifecycle method of EasyMock. Replay will play back all the recording done in your expect lifecycle method, right? It is nothing but here we will So by doing this, what it does is it will just set up the mock object and it will start playing on it. So here in expect, we will inject the behavior of multi-service, that is multiplication service mock object. Behavior is nothing but the multiply method invocation. In expect lifecycle method, here we will just inject that, and replay method we are just playing back by invoking the service mock object. So this will do setting up the mock. Now, one more major thing is I need to test it. Test it is nothing but the verification. Verification is required. So what will I do for that? Next lifecycle method, that is dot verify. So in this, what will I verify? The multi-service object. Yeah, we will verify whether the service object has been executed, whether it has been played, all its behavior by replay, and also whether it has been followed the order. Since we have used strict mock here, verify also depends on the invocation of lifecycle method what you're using. If you're using strict mock, verify will verify the order of which you're following the test method executions. Right, once we are done with, we are also left out with verifying the result. We need to check that using JUnit assert statements. So how we do that? Now before doing that, when we use JUnit, we need to invoke this service, right? So this is just an easy mock class. Let me come back to this class. I'll go back to calculator class which is already there, created earlier. What will I do here is I will use that private interface which has been created. I'll generate the getter and setter for it for multi-service object. Yeah, for this interface object, I've generated getter and setter. Can you see this? So in this existing calculator Java class, I am declaring the service object, which is the interface. If you want to recall it, service multiplication service is an interface which has got multiply method declared in it, right? So when I go back to this Java class, I've just declared that object and added getter and setter methods to it. Now I will try to use this service object. So in order to use that, what will I do? Here I'll write a method which will tell me multiply. Yeah. Now here what I'm writing is it will just return me multi-service object multiply when I do just 1 into 2. So what am I doing here? I've just declared this object. I've created getter and setter and I'm just using this method. Now I'll tell you why the reason behind using this service object inside this Java class, right? Once I'm done with, I'm going to this easy mock test. Yeah, when I come here, I need to declare the calculator and initiate the calc object here. The reason we are doing this is the calc object has got a method which I'll be invoking here. So here in test method, what we have, we just write the invocation for our calculator object. So what is that? Calc object dot multiply, right? What does we multiply? 1 into 2. Now, this is the basic Java JUnit implementation, right? This is not easy mock. This is just a Java JUnit implementation of line which we have seen earlier also. This is how we invoke, right? We just create an object of the class which you're testing, that is Java class, and you're invoking the method in it. The difference here, what comes is the multiply method is using a service object which in turn invokes multiply. This is how the use of mock object comes into picture. We are using an external file or not an external file, sorry, the interface file, which is service file, which acts as a service file, providing multiply method to use in this class. So basically, how will you implement interface? You implement interface and define this method. But in easy mock, we are making use by creating an instance of mock object without any instance of implementation class. We are mocking the interface service and invoking the method. Okay, that can be through a Java class, or you can invoke like this directly. Okay. The reason of writing this statement is because we need to check using assert statement if is everything working correct. Okay, as I said earlier in previous slide, that JUnit works in conjunction with easy mock. So in order to verify the result, we need to write the assert statement. Here expected will be 2. 1 into 2 will be 2. And here, what will I do? So instead, I'll invoke this directly. You remember, previously I used to initiate with result. You can do in either way. Either way in the sense, you can initiate this with some variable result and then compare with actual result and expected result. Yeah. So, this is the JUnit statement which will verify your easy mock by invoking this multiply method, which in turn calls service object. Now, how will this service object be provided to calculator? It's by providing the mock service proxy object. And how will you make this available to calculator? I'll tell you in the setup method. If you remember the calc object, we had written setup methods, right? This is instead the service mock object. So here the service mock object, whatever I had created using strict mock, will be initialized in calculator class. If you see, this will get initialized when we execute test class. So here I'm done with. So this is the JUnit statement, but these are the easy mode statements. So in order to make this mock object available, I am creating a lifecycle method, create mock, and then initiating that with mock object. This is the mock object for the service interface, and then I am expecting that using the lifecycle method, which will directly invoke the multiply method and then give me the expected result with using and return method. And replay is again a lifecycle method. It will replay all your recorded or expected behavior what we had done in this expected lifecycle method. And once you are done, you have to verify it. One more very important thing here, what you have to see is when we forget to write replay in easy mock, what happens is it will throw illegal state exception because you are just writing easy mock expect without replay statement. It is an illegal for easy mock to execute. So expect should always follow with easy mock the replay. So this is an order. It's a sequential order which where after expect lifecycle method of easy mock, you need to invoke a replay of easy mock lifecycle method. This is a sequence of order which you have to follow. If you forget to write this replay method, it will throw illegal state exception. Once you are done with, it has to be followed with verify of easy mock lifecycle method. And this is important because it will verify the way you are executing your test case methods. Understood? I hope it is clear. And then the result, what we are doing here, it's a JUnit statement in order to check how the mock object will be initiated by easy mock class. And here, mocking we have seen, it's all about providing a resource to a class by proxy object using easy mock create step. So here what we are doing, we are creating an instance of multiplication service and directly giving that as of a mock object and making it available to calculator Java class so that we can call any number of methods inside this service object. So this multiply method will in turn call this service multiply. So this is how it works. Now let me execute this. Rest all remains, the template remains the same. These are the basic life cycle method which need to be followed. These are all coming from JUnit, and these are the life cycle method which are followed from easy mock. So it is creating a mock of interface object. Now let me execute this. Execution remains the same. Select the easy mock test, run as JUnit. So did you see this? It has executed your test method by executing these statements. Expect, replay, and then the multiply 1 into 2 has returned me the result, and also I have verified using assert equals. So this is how you test and verify using JUnit that I have executed and tested it. And this is the mock object where you again invoking it directly by mocking the service object, and we are testing the same through calculator Java class by providing the service object. Here we will provide the service object to set multi-service method. So this is the typical easy mock class where we mock service object. And all these mechanisms are provided by Java proxy. And it's very useful in enterprise Java applications when we deal by testing the application code which will actually use the services like interfaces. It can be any interfaces, and then we will mock all those without going to actual implementation class. In turn, we'll just mock the service class. So here if you see the magic behind easy mock is nowhere the implementation is coming into picture because multi-service is an interface. To make use of this multiply, you need to have implementation class. But here we are not reaching till there to test that implementation class. Whereas we are creating a mock object of service itself and invoking that using these methods. We are not bothered about implementation classes. This is how you provide mock object of your interfaces and make it available to all the Java classes which make use of those interface service classes. So that is the concept of easy mock. Now this is the easy mock execution. Now let me tell you how will we execute or do the debugging in JUnit, right? For that, I'll go back to this JUnit class. This is our JUnit class. So in this JUnit class, what will I do is very simple. Take this test add method. What will I do is I will make this as 4. So when I make this 1, 2, what will it do? It will do 1 plus 4 as 5. It will give the result, and in assert equals, I'm comparing the expected with actual result. Actual result will be 5, but if I say expected is 3, obviously it will throw an error. So let's see. I'll execute this. Did you see that? It has thrown me an error. So what is the error? Error is expected is 3, but it has to be 5. But actual is 5. How can you expect 3? That is the error what it is showing in your failure trace. So this is how you check that there is a mistake in your expectation. It is not that it is returned as 3. The output what you get it from the method what you execute in your Java class is 5. 5 is by adding these two numbers. But here I am expecting 3, so this is wrong. What I need to do is to make it 5. And then again I'll execute. So it has got executed. Now this is the error and how I fix the error. Now let me debug it. In order to debug, what will I do is I'll put a debug pointer. This you can put by right click on it, right click on this bar. What you can see is the blue bar. You can just select and highlight here whichever method you want to test. For example, I need to test subtract. I'll come here and do right click and toggle breakpoint. So breakpoint has come here. Now in order to remove this breakpoint, I'll disable this. The same thing applies if I want to test. I'll do toggle breakpoint. It will give me the breakpoint. Breakpoint means if I execute the code, it will stop here because I need to debug it. Debug is the step-by-step process of knowing the line statement result and also debugging your wrong bug fixes or wrong statements or bad coding in your code which will cause failure in your program and which will result errors. So for all those things, if we know which part is throwing the error, I will put a debug point. In order to regenerate the error, what will I do? I'll change this 5 to 3. So in this case, I'll get an error, right? I'll run as. So I got an error. So the reason being, I'm adding 1 plus 4, but I'm expecting 3, which is wrong, right? So I need to debug this to know where is the error happening. I know where it is by failure track. If I double click on it, I'll get to know this is the method which is causing the problem. So in order to debug it, as I said, you just go right click and there is a toggle breakpoint. Just select this, you will get a breakpoint here. So what happens here? I'll show you. You have to select your test class, that is JUnit test class, right click, and since we are doing debugging, select debug as what? It's debug as JUnit. Now it will ask me the perspective view in which I want to see. I'll say yes, it is in debug perspective. So it will go to debug mode. In debug mode, what it happens is, if you see here in right hand side, it is there in the debug. So this is the perspective view of my debug. I have put a breakpoint. If you see, it has stopped here. So it has stopped execution till here. Further, I need to see where is the problem. So in this case, when I'm checking it, the same you have to also check in a debug console. It give me the stack trace of where is my debug breakpoint and where will I go further. So how will you debug? There are icons. Step into 5. It means you are getting into the debug. It's a normal process of Eclipse how you follow. For any Java code, you follow the same process. JUnit is also the same. You just debug it. And here, if you see this icon, it is step over F6. All these are the shortcuts. And F7 is your one more which says step return. It comes out of the method where you are testing it. And this is the next statement. So you can use all the shortcuts or you can directly click on this icon. See, I'll click on step into. It means it will go to the next line. If you see here, breakpoint was here, right? It was in this line. When I did step into, it has gone to next line. So here what I can do is, I can inspect this result. Let me go to step into. What will this happen is, it has invoked add. Just because I've invoked the add method in this line, so it has got into this class to invoke add method. So what will this do? It has got x is equal to 1. If you highlight this cursor into these variables, it will show you the parameter values what you are passing into the method. So here if you see, y was 4. So here x plus y will give you 5, right? You can see this by selecting this, or you can also see here in variables. Shows you if there is a window in debug perspective, it all will come by default. You just need to go and check the values of it. Once it is done, again I'll press F5. It will come back here by invoking that add method in your calculator class. And again when I press this, you see here in variable right hand side, you can see the result 5. So after executing the add method in your calculator Java class, I've got a result 5. But in assert statement, I'm expecting 3, but the result is 5. So what will that assert equal does? It will check the values of expected and actual, right? So when it checks that these two are not equal, it will throw an error. So I got to know by debug that there is a problem of my expected value. I should change it to 5 to fix the error. So this is how you debug. If you know the assert equal does the comparison of these two things, I need to know what is the value of it. To know the value of it, I'm putting the debug breakpoint wherever the test case is failure using the failure track I saw earlier, and I'm further moving ahead. I'm just done with this and press run. So it has got executed. I'll again switch back to Java mode to fix the line error. So if you see, I was talking about this failure track. Here when I get to know there is a problem here, put a debug point and just see what is the problem. So problem I got to know is, I have put the expected as wrong. It should actually be 5. I'll change it back to 5 and then I'll execute that test class. It should give me the success. So this has successfully run. All the test cases has run successfully with 0 error. So this is how you debug in your JUnit. It's the same process what you do for any Java class. Not only in JUnit, but even in Java class you do the same thing. It depends whether you want to put an add class or you want to put an add in this calculator class. So wherever you put, based on that breakpoint, the execution stopped there. Now we are done with the execution and also with easy work example. Let's see what is there in our next course of our training. We are done with this. We have executed all the test classes. We have also seen how we do debugging in JUnit. It is the same way what we do for Java classes. And also we have seen the example of easy mock where we have mocked the interface service or the interface class and then provided that mock object for all the Java classes which uses the interface. We can also directly include that by using all the easy mock lifecycle methods. And also we saw the sequence order which has to be followed using lifecycle methods of easy mock. It works with the conjunction of JUnit, which is very much important. You can make use of the assert statements, lifecycle methods, all the details or APIs provided by JUnit in EasyMock because it comes along with all.JUnit. Now, best practices of JUnit. I've already said many practices so far which we came across throughout this course, which are very important. To recall, naming of the file name in JUnit and naming of the fields name, naming the test method names, then following the annotations, assert statements. All these are the best practices. Let's see what JUnit says. When writing test, consider the following questions. Here, practices are put in questions. It means what practice should we follow? It comes by answering these questions. What are those? When do I write test? So when should you start writing test? It's earlier course material which we saw in the slide. It very clearly said the JUnit idea is start testing before coding. So it means you start writing your test cases before starting the code or implementing your code for the business requirements. So you should know before and when you start writing the test and you clear all the steps and then start programming, you will find the actual better quality the programmer gets by developing his code. Do I test everything? Yes, you need to test everything what you write in your JUnit. JUnit basically consists all the test methods because whatever you write in your Java, you want to test. That's the question which is asking you, do I test everything? So you need not miss anything. So you have to write everything in order to provide better delivery of your code with quality outcome. How often the test should be run? So this is also very important. Why this question arises is whenever you have any Java file performed and done with all the scenarios, test cases and done with the production as well. After production, if you're coming back with fixes, bug fixes or enhancements or anything as such, you should come back and work on the same Java which has already been tested. But you're modifying the Java file. In order to modify and then test it, you need to keep running your test classes so that to check where the programs are getting broken. So JUnit test classes will also track you the breakage of your changes or modifications done for your Java application project. So this is very important that you keep testing your test cases in your JUnit very often to keep track and add a sync in both Java class and also in your JUnit test class. Why use JUnit instead of println or debugger? This is also an interesting question. You can test your Java code by println. You can also do by debugger. Just now earlier we saw an example, right? By debugging we saw the value of result and expected. So there you can put a statement and directly see in the console and compare and see, okay, this is the problem and fix it. But what is the reason of having JUnit? It's very simple. You don't want to make your code filled with println statements, and it is so cumbersome. It will be very non-readable code and not a best practice at all. It's a Java best practice. If you have to follow, remove all those println. It's no for your Java coding standard. So in order to avoid that, you have this JUnit where you can easily, and it is very simple to test and it's fast as well. You can test all test cases in easy way. So that's why we need to go with JUnit. So this we can also check why we need JUnit, right? We need to see what are the benefits of JUnit, and that's why we go for JUnit. Let's see what are the benefits. JUnit testing helps developers find errors in code. It will help you to write better code. Unit testing saves time later in the production or development cycle. As I said, unit testing is one of the important phase in your software development life cycle. And once you do unit testing, it assures you a quality product to be delivered for the customer. And it's very important to follow this unit testing, and JUnit will come in hand to support unit testing in Java. Especially for developers, they can provide error-free code. Unit testing provides immediate feedback on the code by knowing what is wrong and where it is going wrong. So that is was all about JUnit. You saw the benefits of JUnit, you saw the ease of using JUnit, and also the importance of unit testing. So unit testing is all about software development lifecycle process, delivering the quality product. And JUnit will come in hand with easy mock, and you can do all your mocking of objects when you are writing your Java applications, and you can deliver the best product by using these technologies. So all this framework what we saw so far are testing framework, and this comes the end of the slide. Thank you.